Hello, everybody. So, in this lecture, we are going to discuss some numerical problems from this topic. Okay, so first of all, we will discuss the numerical problems about projectile thrown horizontally. All right, so the projectile is given some initial horizontal velocity and then it falls down following a parabolic path. So, the first exercise here, a hiker stands on the edge of a cliff 490 meter above the ground and throws a stone horizontally with an initial speed of 15 meter per second. Neglecting air resistance, find the time taken by the stone to reach the ground and the speed with which it hits the ground. So whenever you do the problem or numerical problem in the projectile numerical problem, what you need to do first of all is to draw the diagram. You have to get a clear picture of the diagram. All right. So let us imagine that the cliff is something like this. Say this is the cliff and the height of the cliff is already given. Height h is already given to be 490 meter. So that means from this point to the ground, that is 490 meter. Okay, and what happened here, a ball is thrown. That means this ball is given an initial horizontal velocity. It is thrown horizontally. Okay, so it is given an initial horizontal velocity u, which is already given. How much is the horizontal velocity? 15 meter per second. So this ball, what it will do is it will fall like that, isn't it? Let me take this curve scale. So from this point, the ball will follow a parabolic path and it will strike the ground at some point. All right. So in this question here, they asked us to find the time taken by the stone to reach the ground and the speed with which it hits the ground. So at this point, the stone will hit the ground at what speed? Okay, so imagine the stone is here just before it hits the ground. Do you agree or not that the speed or the velocity is in that direction? Okay, that is the velocity, the final velocity. All right. And the horizontal velocity will be, horizontal component of this velocity will be in that direction. Let me draw this nicely. In fact, let me use this rectangle. Okay, because we have to resolve this into its rectangular components. Let me make this eraser a little bit smaller in size. That much will do. Okay, so this will be Vx, the horizontal component of the velocity, whereas this is Vy, the vertical component of the velocity. Okay, so one thing you remember in our discussion in the theory of the projectile, what did I say? I told you that when the projectile is flying in the air, the only force acting on it is gravity, which is downward. So this horizontal component of the velocity will be constant everywhere along the path of the trajectory. It will be constant. So if the horizontal velocity here is 15 meter per second, here also it will be 15 meter per second. We need to find the value of v. Okay, so first of all, the first part of the problem here is to find the time. Number one, to find the time. Now, how do we find the time? So the time, how long does the body take to go from this point to that point? Okay, in projectile, the body will take the same time in going from here vertically down. Are you getting my point or not? Suppose you throw two bodies simultaneously. Okay, simultaneously means at the same time. you throw two bodies. So one body you throw horizontally and the other body you just dropped. You just dropped. Okay, you're not throwing, you just drop. So what happened is the two bodies, they will reach the ground at the same time. One body will go this way, one body will go vertically downward, but both of them will reach at the same time. So therefore, in order to find the time that a body goes from this point to this point along the red path, all we need to do is to find the time that a body will go from this point vertically down. So let us consider the vertical motion. For vertical motion, okay, we already have this vertical displacement h, and then we want the time. Let us use the formula. Which formula shall we use? Let us use this. S is equal to ut plus half at square, but since it is vertical motion, in the vertical displacement is h, this will be u y t plus half a y t square. All right, and what is the uy out here? What is uy? Uy is the vertical component of the initial velocity. Now listen carefully. When the ball was thrown initially, it was thrown in the horizontal direction. So that means it does not have vertical component immediately after it is released. Okay, it has only the horizontal component. What is the vertical component? That means uy, this will be 0, is it not? And ay is equal to the acceleration due to gravity, which is 9.8 meter per second square. So from here, and height is already given 490, so 490 is equal to 0 plus half 9.8 t square. So from here we can find the value of t. So t will be 2 into 490 divided by 9.8 under root. Okay, so that will be how much? That will be, I can cancel this this and this. If I cancel, I will get 4.9. 490 divided by 4.9 under root. So 490, can I write like this? 490 by 49 by 10, but that 10 will go up, another 0 out here under root. So this 49 and that 49 will go, so this will be root 100. And root 100 is how much? 10. So the time comes out to be 10 seconds. Okay, so that is the first part. The second part of this problem, we have to find this velocity. Okay, and how do we find the magnitude of this velocity? It's very simple. V is just Vx square plus Vy square under a root. All right, so what is the value of Vx? Vx is, like I told you, 15, and Vy, okay, we need to find Vy also. No, we first need to find Vy. All right, so how do we find Vy? Let us do one thing. Okay, let us work it out here. Now, let us use this formula. V is equal to U plus AT. So Vy is equal to Uy plus AYT, right? And Uy here is 0. And AY is how much? 9.8. And the time just now we got it to be 10. So this will be 98 meter per second. So now, after finding Uy and Vx, Vy and Vx, we can put it here. So this will be simply 15 square plus 98 square under root. And if you do this calculation, you will get 99.1 meter per second. That is the answer. Okay. All right. So let us move on to the next numerical exercise. Okay. The second one, a bomb is dropped from an aeroplane when it is directly above a target at a height of 1000 meter. The aeroplane is moving horizontally with a speed of 500 km per hour. By how much distance will the bomb miss the target. Okay, so let us draw one diagram out here. What color shall I give for the aeroplane? Let me give this color for the aeroplane. Okay, so you have an aeroplane which is something like this. Okay, so that is my aeroplane. Let me put a little bit of color also. Right, so this aeroplane, does it look like an aeroplane? Okay, it doesn't look like an aeroplane, but let's just assume that it is an aeroplane. Okay, so the drawing is not important. Alright, so here it says that a bomb is dropped from an aeroplane when it is directly above a target. So this aeroplane is moving this way. Okay, it is moving this way. And which way is it moving? It is moving that way. Okay, with some initial velocity. With some initial velocity u. And how much is this? 500 kilometer per hour. Okay, so it has a bomb out here. This bomb. And it is trying to drop this bomb when it is vertically above the target. That's the target. Okay, and this is the ground. Where is our target? Our target is here. This X is our target. Alright. Make it bigger a little bit. Okay, now since this bomb was together with the aeroplane, so this bomb also will be having an initial velocity in the horizontal direction. Yes or no? Yes, because the bomb was moving together with the aeroplane itself. Okay, so this bomb will have an initial horizontal velocity u, same as the aeroplane, 500 kilometer per hour. Okay, so this pilot is quite foolish, is it not? He knows, or maybe he don't know. If we do like this, when the target is here, he cannot just drop directly above because this is going that way. No, obviously this bomb, it will be flying this way, right? It will go that way. It will miss the target altogether. Yes or no? So he is dropping from here, but then the bomb goes and it hits this point. Okay, so by how much distance will the bomb miss the target? That means we need to find this distance out here. So let's call this point P. We need to find this horizontal distance x. Okay, we need to find this. The value of x we don't know. All right, okay. What is the height of the aeroplane? The height is 1000 meter. Yes, 1000 meter from this point to this point. All right, okay. Now what is the question? By how much it will miss the target? So we have to find the value of x. Okay, first of all, we need to find how long this bomb will take to reach the ground. So just like in the previous exercise, we only consider the vertical motion. Okay, so for vertical motion, you have let's say use the formula s is equal to ut plus half at square. So here s will be h uyt plus half ay t square. So obviously this part will be 0, so t will be 2h by g under root. Do you know why? Since ay here is g. Okay, we are going to neglect the minus sign. So let's just put here 2 into h here is 1000, and the value of g is 9.8. So if you do this calculation, you get time to be 100 by 7 second. Okay, right. Next, what do? We have to find the value of x. So this time as the body goes from this point to this point is the same as the body goes from this point to this point. It would be the same as the body go from that point to the horizontal distance. That means from this point to that point. Are you getting what I'm saying or not? If the body takes, let's say 100 by 7 seconds to go from this point to this point, then at the same time it will travel from this point to that point. Understand? So now we will consider the horizontal part. Okay, so for horizontal direction, for horizontal motion, let's just say for horizontal motion, you have x is equal to uxt plus half ax t square, and this part is 0. Why? Since ax is 0. So basically it is the horizontal velocity with the time. Horizontal velocity here is 500 kilometer per hour. So you have to convert this to meter per second. First of all, how do we convert that? We multiply 1000 and we divide this by 3600 into time. And what is the time? 100 by 7. Okay, so if you do this calculation, you will get 1984.13 meter. That is the answer. Exercise 3. A helicopter on a flood relief mission flying horizontally with a speed u at an altitude h has to drop a food packet for a victim standing on the ground. At what distance from the victim should the food packet be dropped? Again, here draw the diagram. Okay, so let's say our helicopter is this. Okay, so that is our helicopter, let's say. All right, and this helicopter is he wants to drop a food packet to a victim on the ground. Okay, let us draw the ground. Also, let me take the ground with green color. Okay, so that is the ground, and this helicopter is at a height h from the ground. Okay, so let's say the food packet is somewhere here, right? Let's say this is our food packet with yellow. Okay, that's a food packet, let's say at point B. Okay, this is point A, let's say, and the height of the helicopter is h. Now this person is right here. The person is at B. So the question is when the helicopter is how far from this person. So that means this distance, let's call this distance as D. Okay, so when obviously the food packet, how will it go? It will go like this. No, wait, rub off this part first. Yeah, so this is the path in which the food packet is going, and this is D, this is X. So the questions here says a helicopter on a food relief mission flying horizontally with the speed u. Again, the speed u, meaning this initial speed of the food packet will be u in the horizontal direction. Yes. At an altitude h, that means at a height h, has to drop a food packet for a victim standing on the ground. This is the victim. That's the victim. At what distance from the victim, that means from here till here, you have to find the value of D, should the food packet be dropped. Okay, so here what you need to do, first of all, you need to find the time, how long the food packet will take to go from this point to that point. Now we know how to find the time. So we know that T is equal to T 2H by G. Yes, I think we already got this from the previous example, not this one, previous page, this one. See, T is equal to this. How do we come to this formula? By using this formula. Okay, so I'm just using a little bit of shortcut out here. No, where is it? Can't find it. Is this the one? No. Is that the one? No. Is that the one? No. Ah, this is the one. Okay, so I need to close this. Not that one. This one. All right. Okay, so how do we find the time? Just put the value of h. H. Yeah, this is no values are given, so we will just leave it like that for now. Let's call this some equation 1. So to find D, you need to know the value of x, because this is a right angle triangle. We can use Pythagoras theorem. Now how do we find x? Now x is just the horizontal velocity into the time, so that will be ut. Yeah, so this will be u into 2h by g under root. So therefore, how do we find D? D is equal to h square plus x square under root. So that will be h square plus x square. So this will be 2hu square by g under root. That is the answer. Number 4. A projectile has a range. Now this is a different part. This is the type of motion where the projectile is thrown at some angle with the horizontal. Okay, before we discussed this kind of a problem where the projectile is thrown horizontally and the projectile goes like this. So now we will discuss whether projectile is thrown at some angle with the horizontal, and then it will go like that. Okay, so this is the problem, the new type of problem that we will discuss right now. Okay, I want to erase this first, make the eraser a little bit big. Okay, right, so here a projectile has a range of 50 meters. So range is already given, r 50 meters. So it's a good practice to list down the given quantities whenever you do physics problems. All right, h here is the and reaches a maximum height of 10 meters. So a maximum height is denoted by capital H, 10 meter. Calculate the angle at which the projectile is to be fired. That means the angle of projection, how much? Okay, so let us use the given formula. We know that r is u square sine 2 theta by g, right? And h is u square sine square theta by 2g. So therefore, let us divide one by the other. Let us take h by r. Let us take h by r. H by r will be u square sine square theta by g, and if I divide this by r, this will be go upside down, right? U square sine 2 theta. So this g and this g will go, u square and u square will go. Let me work out this a little bit. I think we know this. This is a very popular trigonometric identity, isn't it? Sine 2 theta is what? Is 2 sine theta, 2 sine theta cos theta. Yes, and 1 sine theta will go. Now sine by cos is tan. So this will be half. I think there's a g also somewhere. H, yeah, 2g. 2g. So 1, 2 is already in front. So that will be 1 by 4. 1 by 4 tan theta. Okay. So tan theta is equal to, this 4 goes up here, 4h by r. Alright, and 4h here is how much? 10. R here is 50. So this comes out to be 4 by 5. 4 by 5, okay? So theta is tan inverse of 4 by 5. And tan inverse of 4 by 5 comes out to be 38.66 degrees. That is the answer. Okay, let us do some exercise problems. This is exercise 4.15 from the textbook. The ceiling of a long hall is 25 meter high. The ceiling of a long hall is 25 meter high. What is the maximum horizontal distance that a ball thrown with a speed of 40 meter per second can go without hitting the ceiling of the hall? So let us write down the given quantities first of all. The ceiling of a long hall, 25 meters. So that means the height of the ceiling, okay, capital H here is 25 meter. Got it? So we don't know, it says here, what is the maximum horizontal distance? That means the range. The range we don't know, right? And the velocity with which it is projected is already given, 40 meter per second. Okay, so let us just use the formula. Using the formula, h is equal to u square sine square theta by 2g. All right, so from here we find the value of theta first of all, because we don't know at what angle it is projected. Okay, so sine square theta is 2gh by u square. So sine theta will be root 2gh by u. Okay, so this will be 2. G here is 9.8. 9.8. H is 25. Under root divided by u here is 40. So if you work out this calculation, you will get 0.553. So that is sine theta. So therefore theta will be how much? Will be sine inverse of 0.553, and this sine inverse comes out to be 33.6 degree. So now we can find the range by using the formula u square sine 2 theta by g. So u is already known, 40 square sine 2, what is theta? 33.6 by 9.8. So 40 square sine 2 into 33.6, that comes out to be 67.2 by 9.8. Okay, so if you work out this, you will get 150.5 meter. That is the answer. right? Okay, let us do this last problem for today. This is also the textbook problem 4.16. A cricketer can throw a ball to a maximum horizontal distance of 100 meter. Okay, maximum horizontal distance. So here R max. R max is given. That means the maximum horizontal range is 100 meter. Got it? So what is the distance? The difference between this problem and the previous one? Okay, it doesn't matter. So R max is this much. Here, how high above the ground can the cricketer throw the ball? That means H is equal to how much? Now this particular problem is a bit confusing. Okay, it is a bit confusing because here, first of all, in the first case, that means in this line, the cricketer throws the ball like this. Okay, that means he is projecting at some angle theta with the horizontal. But to find H, now the cricketer is throwing the ball like this, vertically. Okay, so this can be confusing at times. You may make a mistake and just use the value of the formula for H and find this. That is not H actually. Okay, this is not the H that we want to find out here. This one we want to find. Understand? So let me just repeat what I just said. In the first case, the cricketer is throwing the ball, making an angle theta with the horizontal. So this is the shape of the path followed by the projectile. So we know that R max is equal to u square by g. So from here we can find the value of u. So u will be g times R max under a root. G is 9.8, R max is already given to be 100. So this will be root of that comes out to be 31.3 meter. Now in the second case, the body, it is not the same one. Okay, so in the second case, now the cricketer is throwing vertically upward. All right, so vertically upward, it reaches, let's say, till this height. Right, at this height, what will be the velocity of the body? It has to stop momentarily, yes or no? So the vertical component of this velocity will be 0 out here before it goes back down. Understand? So for vertical motion, let us use this formula. Vy square is equal to uy square plus 2gh. Okay, here Vy is 0, u is this 31.3. Of course this now will be uy. All right, 31.3 meter, and h we don't know, and a here is minus g, means minus 9.8. So therefore you have 0 is equal to 31.3 square minus 2 into 9.8 into h. So 2 into 9.8 h is equal to 31.3 square. So h here will be 31.3 square by 2 into 9.8. So if you work out this, you will get 50 meter. That is the answer. All right, so I want you to practice these numerical problems, and I will give you some examples also. Okay, thank you.